Hello everyone, and welcome to the video that I've made on for section 5.2 on integration with natural logs. The objectives for this video are: one, to use the log rule for integration to integrate a rational function, and number two, to integrate trigonomic functions. Let's start out by looking at the log rule for integration. In this case, we're going to let u be a function of x, so that's what's going to happen here. And if I take the integral of 1 over x dx, that is going to be the natural log of the absolute value of x plus c. And if I integrate the integral of 1 over u du, that is going to be the natural log of the absolute value of u plus c. The alternate form for this second version, where we have the chain rule version, if you will, is going to be that the integral of u prime over u with respect to x is going to equal the natural log of u, of the absolute value of u plus c. Now, why do we use the absolute value symbols here? Well, remember that the natural log is defined only when you can only take the natural log of a number that's greater than 0. So in order to go through on these things and make sure that we're guaranteed that we are only taking the natural log of something that we can work with, because we're working with real numbers here, we use the absolute value symbol to make sure we're looking at something positive in there. So that's why whenever you integrate something in the form of 1 over x dx or 1 over u du, you must use the absolute value symbols. At this point, let's take a look at some example problems that I've worked out so you can kind of see how this process is going to work. The first problem that we have is this one right here. It's the integral of x squared over 5 minus x cubed dx. And now I've rewritten this as 1 over 5 minus x cubed times x squared dx. Usually what's going to happen on these is we're going to use the denominator. That's going to be one of our keys on this, is to use the denominator as u to start out with and see if that works. And a lot of times that means what's in the numerator is going to be part of that derivative of u. So I usually kind of pull that off to the side with the dx. It's up to you though. You do have the choice on how you rewrite this. If you prefer to leave it as the x squared in the numerator, that's perfectly fine. But as I said, we're going to let u equal 5 minus x cubed. And then, so I take the derivative. Du then is going to be, derivative 5 is 0, so it's going to be negative 3x squared dx. And then what I did is, because I just went through and divided by the negative 3, so I got du over negative 3 equals x squared dx. And now I can make that substitution. U goes into the denominator, so I get this becomes 1 over u. And this part right there, the x squared dx, we know that's du over negative 3. So I replace that with du over negative 3. So I now have, in terms of u now, the integral of 1 over u times du over negative 3. Now the first thing I'm going to do is take that negative 3, really think of that as du times a negative 1/3. I'm going to pull that negative 1/3 out, so it's now the negative 1/3 times the integral of 1 over u du, which we know from the log rule is the natural log of the absolute value of u. So I now have this equals negative 1/3 times the natural log of the absolute value of u. And again, because it's an indefinite integral, we always need to use that plus c at the end, plus that constant. And so our final answer on this, because we started out with x, we need to finish with x. I replaced that u. I know u is equal to 5 minus x cubed. So this is going to be negative 1/3 times the natural log of the absolute value of 5 minus x cubed plus c. Please take a moment right now, make sure you are comfortable with the process, what I did on this problem, and then once you are, restart the video and we'll take a look at our next example. In this next example, we're looking at the integral of 1 over x times the natural log of x cubed dx with respect to x. And this one illustrates a problem that students have a lot of times, because we start out looking at the problem and people get a little worked up by the fact that there's a natural log in here. In their mind, they've already come up with the idea that we know we're going to have to end up with a natural log of something at the end, but to have the natural log in there kind of can make things look messy or can be kind of confusing. The main thing I have to tell you on this is don't get worked up by this. It is a function. It is possible to work with it. We'll just let u be that natural log. Now, so one of the things I'm going to do with this, the first thing I'm going to do is I want to deal with this natural log of x cubed. That 3 up there doesn't really work for me. So what I'm going to do is I have a log property that tells me that that 3 can be moved out in front. So this now becomes the integral of 1 over 3x ln x dx. Now the other thing is that 1 and 3, that's 1/3. I can pull that out. So this is equal to 1/3 times the integral of 1 over x ln x dx. And the only other thing I would do on this one, because of in terms of working with this, I am going to go and separate this. I can look at 1 over x times ln x as a product of two fractions. So this is equal to 1/3 times the integral of 1 over ln x times 1 over x dx. Now the way this one works then is I'm going to let u equal the natural log of x, and then du then is going to be 1 over x dx. And so our problem now here, that problem, has now just become 1/3 times the integral of 1 over u du, which we know by the log rule is equal to 1/3 times the natural log of the absolute value of u plus c. And again, replacing, knowing that u is the natural log of x, what I'm going to have is this equals 1/3 times the natural log of the absolute value of the natural log of x plus that c. Again, pause the video right now. Make sure you are comfortable with everything that we did on this problem. And if not, make sure to take note of it. But once you feel you're ready, restart the video and we will move to the next example. This next example is going to illustrate a technique that we've used in the past, but it's not very common, but I wanted you to see this one again in terms of doing the integral. So in this case, what we're going to start out with here is the integral of 1 over 1 plus the square root of 3x dx. And so we start out by doing a u substitution. I'm going to let u equal 1 plus the square root of 3x, which by using the exponent rules, I know that square root of 3x is just 3x to the 1/2 power. And so I know that du is equal to 1/2 times the 3x to the negative 1/2 times 3 dx, or I get that it's equal to 3 over 2 times 1 over the square root of 3x dx. Now, the one thing I'm going to do on this one is I do want to solve for dx. So that means I'm going to have to multiply both sides by 2/3 and the square root of 3x. And so what I get when I do that is dx equals 2/3 times the square root of 3x du. And now making that substitution, I went on this one, I have the integral of 1 over u times 2/3 times the square root of 3x du. I pulled the 2/3 and now I have this. Now right away you should be sitting there saying, wait a second, there's a problem. Because of the fact that we know that when we do a change of variable, I can't have any x's left in the problem. And I clearly do have something like that now. So the question is, what do we do? Well, if you think back, one of the techniques we had with this is really coming up and using this up here to help us out. Because I can go through and from that, I can say that the square root of 3x is equal to u minus 1. And so, therefore, this problem now will become 2/3 times the integral of 1 over u times u minus 1 du, which equals 2/3 times the integral. When I distribute the 1 over u, I'm going to get 1 minus 1 over u du. And that integral is going to be 2/3 times the integral 1 is going to be u minus the natural log of the absolute value of u by the log rule plus c. Or we get our final answer here is 2/3 times u, which is going to be 1 plus the square root of 3x minus the natural log of the absolute value of 1 plus the square root of 3x plus c. Now in this case right here, the absolute value symbols are redundant in this particular portion of this, because of the fact that 1, we know that the square root of 3x by definition is always a positive value. So I'm taking 1 plus a positive number. This thing will always be positive. And so instead of having the absolute value symbols there, I am able to go and use parentheses on that one. So I could have on this problem, let me kind of shrink this up a little bit, move it. This can then be thought of as equal to 2/3 times 1 plus the square root of 3x minus the natural log of 1 plus the square root of 3x plus c. Well, let me close that off there. There we go. That plus c should be on the outside, not on the inside. That way, not this plus c right here should be on the outside. So with that, this completes this problem. Please, again, as before, pause the video right now. Make sure you're comfortable with everything that we've done, because there's a lot of stuff that happened on this one. You start out letting u equal this, all the stuff we did in red here, how that ended up being substituted in to give us the yellow, how the blue, what we found here, was used at this point to get our final answer, and then substituting back into the white, and why we used the absolute value symbols here, and why I was allowed to drop the absolute value symbols and just use parentheses at the end. Once you're comfortable with that, please restart the video and we'll take a look at our next example. This next example should be one that you're already somewhat familiar with, because you'll notice that once we finish this, it's a problem that you dealt with earlier in the last section. What we're going to look at here is the integral of the cotangent of x dx. And what I'm going to do on this is I'm going to use the fact that cotangent is equal to cosine of x over sine x. So this now becomes the integral of cosine x over sine x dx. And we're going to do this with a substitution, just like we have before. I'm going to let u equal sine of x, so du is cosine x dx. And so making that substitution, replacing sine x with u, cosine x times dx is du. This now just becomes the integral of 1 over u du, which we, again, by the log rule, we know is equal to the natural log of the absolute value of u plus that c. And so, u being sine x, it is equal to the natural log of the absolute value of sine x plus c. If you remember from the assignment from 5.1, you had this problem where you were supposed to take the derivative of the natural log of the absolute value of sine x, and what you should have come up with in that case was that it was the cotangent of x. Again, this one, pause the video. Make sure you are comfortable with everything that we did there. If you are, then once you are ready, just restart the video and we'll move into some of the formulas that you're going to have to do, some additional formulas you have because of this integration here, and others that we can do as well. We have the integrals of these 6 basic trig functions. These first 2 up here were ones that you already know. You know the integral of sine u du is negative cosine of u plus c. And we've talked about how the integral of cosine is going to be sine of u. So you have that one. Okay, and that should make sense to you because of the fact, again, you know that these are antiderivatives. And so when I take the derivative of this, I have to get back to what I have inside the integral on the left. In the next 2 in yellow, the integral, this second one we've already done. We just did that one as an example. This also works for the tangent. The integral of tangent of u du is equal to negative natural log of the absolute value of cosine of u plus c. And the last two that we have are working with the integral of secant and cosecant. The derivation of these formulas are examples in your book. Well, for secant is an example in your book. If you would like to take a look at that, you may. Or if the example is not quite clear as to what happened, if you'd like to talk about it, we can go over it as well. But regardless, the integral of secant of u du is the natural log of the absolute value of secant u plus tangent u plus c, and the integral of cosecant u du is equal to negative natural log of the absolute value of cosecant u plus cotangent of u plus c. Now, when you're working with these problems, please keep in mind that you are going to have to, these can be calculator and non-calculator problems. The non-calculator problems would be working with angles from the unit circle, so please make sure you are ready to work with that as well. You should really, at this point, you should know that unit circle pretty much front and back without really any issues. If you do not, you need to start getting ready, get that thing memorized, make it so that it's pretty much second nature. Let's take a look at an example involving an integral of a trig function. In this case, we want to find the area of a region bounded by y equals 2x minus the tangent of 0.3x, x equals 1, x equals 4, and y equals 0. Well, the y equals 0 is the x-axis. So really, I'm looking for the area between this curve and the x-axis where x goes from 1 to 4. And so I set that up as a definite integral, the integral from 1 to 4 of 2x minus the tangent of 0.3x dx. And I'm going to break that up into two pieces. Now, I don't have to do what I'm going to do now, but I did this to kind of look at this problem as two separate problems, but you can do this all together if you want. The first thing I'm going to do is I'm just going to deal with this portion right here, okay, because that's the piece that I can do without really doing any substitution. And so I know that the integral of 2x dx is just going to be x squared, and that's going to go from 1 to 4, and it's still going to be subtracting this portion of that definite integral. So notice I'm not touching that yet. I'll deal with that down over in this area. And so when I do that, that's going to be 16 minus 1 minus that integral, or I get 15 minus the integral from 1 to 4 of tangent of 0.3x dx. So in this case now, what I'm going to do is I'm going to let u equal 0.3x, or 3/10 x. So du is going to be 0.3 times dx. And solving for dx, remember 0.3 is 3 over 10, so dx is going to be 10/3 du. Now the other thing I want to do, because it's a definite integral, I do change the limits of integration. When x equals 1, I put 1 in for x, I'm going to get 0.3 for u. And when I put 4 in for x, 0.3 times 4 is going to be 1.2. So this is going to become 15 minus the integral from 0.3 to 1.2 of the tangent of u times 10/3 of 10/3 du. And I'll pull that 10/3 out, so I get 15 minus 10/3 times the integral from 0.3 to 1.2 of tangent of u du, which we know is equal to 15 minus 10/3. The integral of tangent u is negative natural log of the absolute value of cosine of u, where u goes from 0.3 to 1.2. Now, I did two things here. Or one thing at this point. I went through and I'm going to take that negative and I'm going to pull it out. So this is going to be 15 plus the natural log of 10/3 times the natural log of the cosine of 1.2 minus the natural log of the cosine of 0.3. And when I go through and put that into my calculator, I came up with 11.76856124. You can double check that. Hopefully I didn't make any mistakes when I entered it. And then that would be approximately equal to 11.769. So this now concludes the video that I have on integration that will involve natural logs. So what you see in this video, you've seen some examples of some of the integration that you're going to have to do. and the application of the log rule. And we've also now seen we have 6 new, well, I actually think of it as 4 new integration formulas, which deal with, we are now able to integrate all 6 of the basic trig functions. And yes, you do need to have those formulas memorized along with the other ones that we have done so far. So with that, I hope you have had that everything is going well and you are feeling okay with this, and we will see you at our next class.